Okay, so welcome to section 1.5, which is techniques for solving problems. So, techniques of problem solving. Oops. Okay, so one technique is working backwards, right? So working backwards. Okay, so this is starting from where you want to end up and going backwards with respect to what's given. So starting from where you want to end up. You want to end up and going backwards. And let me say working backwards. Backwards. To, or with respect to what's given. With respect to what's given. Okay, so what do I mean by this? So for example, so what number results in 21? So results in 21 after you've tripled it. So after you've tripled it, and subtracted 6. And subtracted Okay, so what's the end? Well, it results in 21. So end result, that's where I end up, right? So I need to work backwards from there. Well, after I've tripled it and subtracted 6. So the final thing before I get to 21 is subtracted 6, subtracted 6. So this means add 6 to 21. To go backwards, right? I'm working backwards. So that's going to be 28, right? What's the next step working backwards? I've tripled it, right? Tripled the number. Oh, wait. Wow. 6 and 21 is 27. Oh boy. Addition, not my strong suit. Okay, so 27. I was like, that's not a multiple of 3. Anyways, it's a good thing I caught myself. So I've tripled the number, which means basically I've multiplied it by 3. So to undo that, I'm going to divide by 3. Divide by 3. So what am I dividing by 3? I'm dividing 27, the previous result, going backwards, by 3. So 27 divided by 3, that gives me 9. Okay, so I claim that the number is 9. Well, let's check. So check. So if I started with 9, and I tripled 9, and then I added, then I subtracted 6. Well, what would this give me? This would give me 27 minus 6. And is that indeed 21? Yes, it is. 21, check mark. So working backwards did get me to the 9. So this is what I'm looking for, 9. Okay. Okay, so now let's do pattern recognition. So this is the next type of problem solving. So pattern recognition. So pattern recognition. So with pattern recognition, always try to identify counting numbers. In the pattern. That is, i.e., 1, 2, 3, 4, etc. Counting numbers. So for example, so let's find the pattern in the following set of sums. So find the pattern in the following set of sums. Following set of sums. Okay, so let's see. Let's start off with blue. So 1 is equal to 1. Seems silly, but let's try 1 plus 3, which is equal to 4. Okay, still with me? Still making sense? Let's do pink next. So let's do 1 plus 3 plus 5. So I'm adding odd numbers, right? Plus 5. So 5 and 4, that's going to be 9. Now let's do the next one. 1 plus 3 plus 5 plus 7. Okay, so that's going to be 16. Now let's do, pardon me, 1 plus 3 plus 5 plus 7 plus 9. So that's going to be 25. One more for good measure, shall we? Let's do 1 plus 3, 1 plus 3 plus 5 plus 7 plus 9 plus 11, so that's going to be 36. Interesting. Oh, what the heck? Shall I do one more? Because I just can't help it. Go full circle. Let's do dark blue for this one. So 1 plus 3 plus 5 plus 7 plus 9 plus 11, and then plus 13, right? So 13 to 36 is 49. So this is interesting because 49 is a perfect square, right? 49 is 7 squared, or 7 times 7, right? 36 is 6 squared, 6 times 6. 25 is 5 squared, 5 times 5. 16 is 4 squared, 4 times 4. 9 is 3 squared, 3 times 3. 4 is 2 squared, 2 times 2. And 1 is 1 squared. So what's the pattern here? I see my counting numbers. 1, 2, 3, 4, 5, 6, 7. So those are my counting numbers I was looking for in my pattern. But notice how many terms are in each. So there's one term here, and the number is 1. There's two terms here, 1 and 3, and the number is 2 squared. There's three terms here, 1, 3, and 5. The number is 3 squared. There's 1, 2, 3, 4 terms in this next sum, and the number is 4 squared. There is 1, 2, 3, 4, 5 distinct terms in the next sum, and of course the number is 5 squared. There are 1, 2, 3, 4, 5, 6 terms in the next sum, so it's 6 squared. And I stopped at 1, 2, 3, 4, 5, 6, 7 terms to get 7 squared. So what am I adding? I'm adding odd numbers. So the pattern here is as follows. The pattern is that the sum of the first any integer you like, n odd numbers. So the sum, remember sum means addition in math. So the sum of the first, let's call it n odd numbers, where n is like 1, 2, 3, 4, 5, is equal to 2. Well, if I add one odd number to himself, I get 1 squared. Oops, what's going on? I get 1 squared. If I add 3 odd numbers to himself, I get 3 squared. So if I add n odd numbers to itself, I get n squared. So that's a pattern here. So this is another way of solving, is always to try and find the counting numbers, the 1, 2, 3, 4, 5, etc. Okay, so that ends section 1.5.